So let us start today's session. So finally, from last 2 weeks, we were seeing some videos and we are trying to get some input from the videos, like how to model this truss and how to analyze and design the truss. So finally, today I'm going to tell you the best uh, way of modeling the trusses. And to complete this quickly, I'm going to do the model for today's class. So you have seen the previous classes that how to edit the ETabs loading, how they have kept so how they have gone through the other files and there they have edited in the text file, and also um, the application of wind loads, which was very complicated. And I told you that this will be you have to do the manual calculations and you have to apply the loads for that. Okay, so the calculation part, the wind load calculation, the code that is used is IS 875 part 3. And after as per those codes, they have calculated the pressure coming onto the roof and they have applied the loads. So today I'm going to model a truss and completely analyze this truss and design the truss, and we'll see what are the important points to be followed while designing this truss. So before starting the model, I have given a few uh, models individually. I would like to know the status of those models that you have already done or not, at least till the geometrical part. Shankar, Gayatri, Vivek, Murthy, what is the status? Have you done the model of the sizes? I have given the sizes also, right?
Sir, I still didn't get my laptop, sir.
What about Gunashankar?
Sir, as I told you yesterday, the video was very blur. I missed the first class. When
Yes,
I'm
but
checking the
modeling also
video,
is
I
not
can't
model.
follow the
Modeling
properly.
also is not coming. Modeling also is not coming properly.
So from the beginning of the first, yes, sir, from the beginning of the first 10 minutes onwards, the video is completely blurred, sir.
But you
So
can
only I
follow
can't
the
follow
steps.
the
No, completely
steps.
blur. It is completely blur.
Yes,
It is
sir.
completely blur.
Yes, sir, it's blur in starting.
Which one is blurred? I have given three titles. One is the installing ETabs file is one, dead load, live load, and wind load calculation is one, and truss model is one. Modeling is one. Three videos
Plus
I have
model
given.
is blur, sir. Installing ETabs is clear, sir.
It is. It is. What it is blurred? It is not blurred. I'm just opening it and saying it is so clear. It is so clearly visible. There is no blur over there. So clearly it is visible, no? Where it is blurred, I can't understand. You are not able to see it. Can't see able to see the video. Yes, Shankar and Vivek. You are saying that it is blurred. I am just saying now from the link and I have opened. It's not blurred. It is clear.
From exactly 11 minutes onwards, sir. 11:01.
Should I share the screen? See how it is. It is clearly visible. I'm seeing it now. See this one. It is blurred, but it is clearly visible now where the options are there. Here you can see.
So the height of the PB shed has to be 2000. That is 2 meter. Left click on OK.
Yeah, you can see the nodes over there. Nodes are there.
So
Nodes
now
he has
you have
created.
drawn a joint here. Again, click the base point, go to edit copy and edit
Yeah, you are
paste.
able to go to the place now. He's saying edit copy that option. It is clear only. There is no blur. It is not properly visible. The numbers are not visible. He's saying the numbers also. No. You need spoon feeding for this one. I'm talking to you only. Do you need spoon feeding? It is so clear. You're at an MTech level. You can listen to his voice also. The voice is also clear. So I just repeat once again. So here today we are going to select the truss model. Different shapes are available. In these different shapes, depending upon the span, depending on the span that is given to you, or it is required as per the field conditions, the truss size should be this much. Then according to the distance, you have to select the types of trusses. Okay. Normally, you can see that this trusses. So this we are having generally the truss size we are having is approximately uh, 10 meters, less than 10 meters. So you can go with this HOW truss, HOWE, less than 10, or you can go to Fink truss, F5, and Fink truss, or queen post or king post. Anything you can do, right? So I'm going to model a truss with these properties, which is written over here. This 16 into 8, and the height as 3 meters. So for this, when I have shared you the other videos there, we have done it by point, right? That is, we have created the nodes, then we have assigned the members, and we have followed. Now I'll teach in another way by using the grid system. I'm going to create the model and complete it. So generally, you can see over here, number of grid lines in X direction. That is, in X directions, how many grid lines should be there? So we need only 2 grid lines. So the distance in the X direction is 8 meters. So I'm keeping it as 8. And number of grids along Y directions, that is along this, along this direction. So we need how many grids in this direction? 1, 2, 3, 4, and 5 grids along Y. So this is our Y axis, and this is our X axis. So X is 8 meters distance, right? So I'm keeping it as I'm keeping this number of grids in x-axis is only number of grids. So it is only 2 grids. Okay, 1 and 2. Number of grids along y-axis is 5, and spacing of grids is along x is 8 meters, and spacing of grids along y is 4 meters. Okay, and height over here, number of stories, I'm going to give only 2. Typical story height as 1.5, And bottom story height, I have given some I have given 3.54, or I don't remember, so I'm going to take approximately 3.5 as the floor height. Okay, and this is my input. Click on grid and say okay. So this is a different way of doing it. By using the grid system, I am modeling the structure. So before you have gone through the, without grid, you have seen the videos how to create the members and assign the uh, uh, assign the properties for those members. Now, once you create this one, I'll close this window. I'll just have only one window. This is my window. So now you can see 1, 2, 3, 4, 5 grids are there along y-axis, and along x-axis only 2 grids are there. The A and B are here. At the top, you can see A and B are the grids in x-axis. And height of 3.5 meters, and from this 3.5, this is 1.5 meters for the model. So now what I'll do is that I'm going to create the truss uh, over here. So, but before creating, I think I need one more grid over here. It will be easier for me to create the mid joint. So if I talk about the in between, if I have another grid like this, it will be easy for me to connect it. So what I'll do is that I'm going to create the grid system. Go to edit option, edit stories and grid system. Click on this grid system. I want this grid system to be edited. Modify the grid system. If you click on modify the grid system, you will have these options over here. And over here, X grid data is there. Can you see this X grid data?
Yes, sir.
Yeah. Over there, you can add another grid, right? Like this. But the distance is doubled, so I can change the distance to 4 and 8. Now this, in this way, I have created another grid in between just to simplify my geometry. Okay. So like this, it is going to come. So now over here, let us start the modeling part. That is assigning the members. So before assigning my members, go to the define and give the material properties. So add new material, click on add new material, and as per the Indian standard, the steel material is here you have rebar and steel. You have to select steel because this is not concrete filled with steel. Sorry, steel filled with concrete. So here you have to select steel, and then there are two grades, that is Fe250 and Fe345. So the normal one is Fe250. So give Fe250 and say OK. Then you have material name as you can give the material name Fe250, and or you can give the name as steel, or you can give it is better Fe250 only. You give. Then remaining properties you keep it like that. Basic properties you can leave it like this only. The weight per unit volume is 76, which is a standard one. Then the mass per unit volume, and you have the mechanical properties of here, like modulus of elasticity, Poisson's ratio, coefficient of thermal expansion, shear modulus. Everything is same. Okay. And then say click on OK. So these are the advanced options. If you want to make any changes, you can make changes. If you go to the nonlinear data, it is quite uh, advanced procedures that is not required for the analysis of truss. So click on OK. So once you click on OK and click add over here and say OK, then go to the define section properties, frame sections, and click on the import new properties. Because it is a steel structure, you have to go to the click on new import properties, and here you have steel. Okay. You can click on the steel and you can select the sections that are required. Now we have to uh, you have to first select the type of members, like this. You can, if this is my truss, like this. Now, what is the members that are required? Right? If this is my model, what is this member size? What is this member? This member you can give it as example. You can take I sections. Okay, you can take I sections for these two, this member, and also for this member also. You can take I section. These two you can take it as I section. This one you can take it as this one also you can take it as I section. Then these members, these truss members, you can take them as angle members. Angle, Indian angle, ISA, Indian steel angles. You can use for this inclined member. That is this one and this one. You can take these two members as channel sections, channel members, and the connecting members also you can take them as channel members. They are called as purlins. Okay, so for this, I'm going to select from the Indian standard side. I'm going to select the material which I've given as for physics, and I'm going to select this. These are the I sections. So I'm going to select ISHB 200, ISHB 200 as I section. Then another one is the channel section. I will select this channel section, and I'm going to select standard ISMC 200 and input another material. We don't have angle section shape over here, so go to this drop down box, click on steel angle section, and select, or you can select this material, and from here you can select the steel angle section, and so here you can select the angle section. You can take any angle section for try. I'm taking 90 by 6 and 100 by, not 90 by 6, 90 by 10 and 100 by 10. I'm taking 100 by 10 and 90 by 10 as two numbers. So 1, 2, 3, and 4. These are the 4 members we have selected randomly. And another channel section also I will select for the purlins. Another channel section also for purlins, that is ISMC 175. Right? So these are the members that we have selected, and now you can start modeling the tower. modeling the shape of this truss. So here I will go to the draw beam option, select the first grid and the second grid like this, and here I'm going to set exactly at the intersection point. So this is why I've created this grid in between, so that you can simply select it at the in between this one. Okay? And click on this endpoint and complete the shape. Okay? And then you can select this first point and the last point to draw the column number like this. Now we have to draw the shape like this. So in between, you have to keep this type of shape, right? This part, these parts you have to draw. So for this, you have to create nodes in between over here like this. Here is one node, here is one node, here is another node. So you have to divide into two parts. You have to divide this one into two parts and this into three parts. Okay, so go to the shape, and now I'm going to divide this one into three parts. So you see how to divide that one. Select the member. You can see over here on the left side bottom, the member is selected. So select this member, go to the edit option, and here edit frame. From edit frame, you have an option divide frames, and you can select into three parts. I'm going to divide into three parts because it is required. So I'm going to select into three divisions. Click on apply and say OK. So I have to select this member and then apply and say OK. Here. So finally I got I have divided this into three parts. So I have divided into three parts of here, and then this member also have to divide it, or we can draw simply two lines over here. Go to the frame option, click on the first point, and you can simply draw a line like this and click on enter. Here also you can draw and click and enter like this. Now you should divide this one so that it should, where there is an interaction, it should actually cut. So I am selecting all these members like this. So I have selected. You can see over here, the left side bottom, three frames are selected. Two joints and three frames are selected. Select these frames, then go to edit option, divide frames again, and this time click on this break at intersection. Wherever there is an intersection, is going to break. Click on apply and say OK. So now it will be divided. So if you select and you can select these two members and click on delete button, automatically these two members will be deleted. Okay, because it has intersected over here, it has divided into two members, and the unwanted members we have deleted. Now you can go to the again draw beam option and click this starting and ending point, and then this starting and ending point like this to complete the model. So we have completed this first part, And now you can use the mirror image, and this side also you can draw it simply by using the replicate option. So for that, what you have to do, you have to select the entire frame, all the members and joints, and make sure that this member is not selected because it will be overlapped. Already this member is over here. This is the in between member, so no need to select this one. So you have to select these remaining members. Then go to edit option, use the replicate button, and here you go to the mirror image, pick 2 points, click on this pick 2 points option, pick these 2 points, pick the first point and the second point and click enter. So select the entire frame. Once again I'm doing it. Go to the elevation view, select all this elevation view and close it. Select the frame members like this. For that, let me go to this option. So I'm selecting these all these members. All these members. Once again, I'm trying it. Go to the radial or mirror. Go to the mirror option. What I'll do is that I'll go to the plan view. Story one apply and say okay. Here I'm going to pick 2 points. The first and the second. Click on apply. If you just click on apply and say okay, it will be reflected. I can see it over here like this. So this is how you can model stress. Now the same procedure, the replicate option, you can select the entire frame, and along along this y direction, you can replicate the frame. So 2 meters to here 4 meters is the interval. So I'll go to the again replicate option. Here I'm going to go to the y direction. Y distance is 4 meters. And how many you want? 1, 2, 3, 4. So already one is there. So 4 members you want. Click on apply. So if you click on apply, it is how it is showing you the image. It is how it is going to come. So click on apply and say okay. So the truss is modeled like this. Now after this, mm, you have to connect in between these trusses. There should be beams. Those beams are called as purlins. So actually we have a problem here is that when we are going to the real frames, there the sheeting that on top of these purlins there will be sheeting. That sheeting distance will be up to 1.5 meters. Maximum it will be 1.5 meters. So you should check that carefully. What is the span of this member? So if you click on this one and go to the uh, geometry, it is 1.4. So it is sufficient. So there is no need of breaking this line again. You have to break this line if it is more than 1.5 so that the sheet will not fit over here. Since it is now 1.54 only, which is visible over here. Can you see this 1.424? That means the sheet will fit exactly over here. And we'll check this one also. This member also, it is 1.424. So equally this one also will be 1.424. So you are going to no need to create additional breaking of this member. Now you can select the joints. You can select these joints and this joint and this joint. Select these joints and then you can go to the same replicate option and linear in which direction? Y direction. You have the distance is 4 from here to here 4. Like that, how many you require? 1, 2, 3, 4. So if you click on apply, you have to use this extrude, not the replicate over here. You have to use the extrude button over there. Select these members and then go to the edit option. Click on extrude and extrude join to frames. So we have selected the joints and if you click on this one, it will extrude linearly in y direction. So what is the distance in y direction? 4 meters. And like that you have four bays. This is 1, 2, 3, 4 bays. And each bay is consisting of 4 meters. So click on apply and say OK. Now within 1 second itself, you have drawn all the lines. And see, these are called as purlins. And the purlin distance, this distance should not be greater than 1.5 because the sheeting will not fit into this uh, frame. That's why it should not be greater than 1.5, right? Then, so we have completed the frame. Now, in the same way, we'll create the over here we have to draw the sheeting. We have to also draw the sheeting. So select the members 2, 3, 4, 5, 6. So these members are getting selected where you can see on the left side bottom 6 frames are selected. Now these frames you can go to the edit option, click on extrude and here in extrude you have frame to shell. Click on this frame to shell and along y direction the distance is 4 meters and number is 4. Click on apply and say OK. So like this you can create this shape. So what is the properties of this roof? What is the property of this roof? If you right click on this one, you will be able to see the geometrical properties and the assignments that this property is under slab 1. So by default, the software will take a slab one, but it is a concrete. As per this one, it is a concrete one. member that it has taken. Now you have to change it to the sheeting. So this is actually not the concrete, it is actually the sheeting. So for that, I have to go to the defined option, material section properties, and slab section, and this is the slab one. So you have to modify this one by going and clicking on this modify show properties. Here you can keep the name as same, and the slab material you can take it as Fe250, and then the modeling type you have to take it as membrane, because this shell thick and shell thin, they are going to be used for different purposes, whereas membrane will does not take any loading. It is only the sheet. It is only the sheet over here. So click on this membrane so that it is not going to take any bending action. It is only the covering only. The load, the weight of this sheet, everything will be taken by the below beams and purlins. And then take, you have to calculate the thickness of this one. 200 is too much. So the membrane, it is going to be approximately 5 mm. The sheet of this one is going to be approximately 5 mm. I will show you that 1 second. Let me go to the website, and the website I'll show you the roof sheeting. So you can see this one now. You can see different types of sheetings and the thicknesses that are there, that are available here. The roof sheetings, different sheetings are there. So the thickness of this is very less. It is going to be around 5 to 6 mm like that. And these are not the materials which can carry which can carry the load. They are only the covering. These are only the roof covering sheets. Okay. And you have many different varieties of here. These are, you can see how they are keeping here, and you can see in this diagram. You can see in this diagram it is 65 mm. This is up to here. This is not. This is not right. This is 65 mm is not right. See this product. So different sizes will be there. Okay. So that we are taking it as 5 mm. The thickness we are taking it as 5 mm, and say OK. And click on OK. So we have taken the sheeting over here, that is 5 mm, and the properties of here. These are the column members, and these are the other column members. So for this we have to now, the geometry part is completed. Now we have to apply the loads on these trusses, on this shape, on this floor, where here we do not give the supports over here. So generally they are all pin connections. So select all the members, select all the bottom floor members like this. You can select like this, or another way also you can select. So select all these bottom members, go to the assign joints, restraints, and click on this translation X, Y, and Z. Click on apply and say OK, or you can select say OK. So all are pinned connections, right? So next is uh, assigning the properties to the members. We'll check these members. So I'm going to, what is the member that it is taken over here? Assignments, if you see the assignment, it is ISLB 600. The section properties over here, it is ISLB 600. So whatever the section we have given is not this one. So we have to change that one. By you can select all the members by going to the elevation view, click on the elevation view one, click on apply and say OK. And you can select all stories, select all the members. Only 2 members got selected this way, that is this one. So the remaining members which are behind this are not selected. So what I'll do is that I'll go to the next view, that is 2. This is 2, right? So select these 2 members. And then again go to, click on this arrow markup, go to the 3 button, the third grid, and select the third grid. Again click on this arrow mark, go to the 4th grid, select these members. Again go to the 5th grid and select these members. So total all the 10 members got selected. All the 10 members got selected. And now uh, go to the properties here from the model explorer, go to the properties and frame sections. In these frame sections, ISHB 200 is the best option. So select this one and simply drag it over here. So you can see that red color is highlighted. That shows that these members will be assigned. Uh, uh, this ISHB 200 will be assigned over here. Okay, so it is been assigned. Right, these members got assigned with ISHB 200 type 2. Next comes to this purlin, this bottom purlin. We are in grid number 5. So what I'll do is that I will select this purlin over here. That is 1, 2, 3, 4, 5, 6. It got selected in grid number 5. Go to grid number 4 now, and again drag a rubber band window like this to select the purlin frame. Again go to the grid number 3, select this one. Again go to the grid number 2, select this purlin, this beam. Go to grid number 1 and select this. So total I have selected the bottom members of here. These members are selected. Now I want to assign this member with IS. These are channel sections. I'm going to assign a new property for this one. IS, I am going to define another frame section, a new one. Import new member, I section. Material is FE250. And I'm going to select ISHB 150 type 2. Okay, and click on OK. So that member will reflect over here. ISHB 250. That member you can assign it to these members. You can simply click on that and drag it to the main window. It will be assigning. So the red color is showing that the whatever you have selected, it is assigned to these members. So if you just simply click the mouse, the members will be selected. Okay. Next is next is these vertical members, these truss members. So for that, what I do is that I'm going to go to the again elevation view, and I'm going to select the elevation 1, and I have to select this. So I'm going to assign it to this member, this, and this. For these members, I'm going to assign. For these members, I'm going to assign angle sections. That is ISA 100 into 100 into 10. So I have selected in the first grid, grid number 1 I have selected. Go to the second grid and again select the frames 2, 3, 4 and 5. Then again go to the grid number 3. Here you can see the grid number 1 is selected, 2 and grid number 3. Again select the members 1, 2, 3, 4 and 5. Then go to grid number 4 and select 1, 2, 3, 4, 5. Then go to grid number 5 and select these numbers again. In this one. So whatever you have selected, you can see in the 3D view, and you can, for this one I'm going to give ISA 100 into 100 into 10. So select this one and move it over here. Now you can see in the red color it is getting highlighted. The numbers which you are giving 100 into 100 into 10 are getting highlighted. So simply click on over here like this, it will be assigned. Okay. Next is the remaining members, that is these inclined members. These inclined members we are in grid 1. Select 1, 2, 3 and 4. Select these members in grid 1. Go to the second grid. Again repeat the same procedure. Select this one 1, 2, 3 and 4. Then go to the third grid. Select this, select this, select this and select this. Then go to the fourth, this one and this one. Then select the fifth one, this one, this one, this one and this one. Right? So like this we have selected all the inclined members now. And for the inclined members I'm going to give 90 by 90 by 10. Select and drag it over here like this. So all the grids you can check it and can assign it. So we have assigned all the members. Then we have these horizontal purlin members. They are called as purlin members. For those members also you can assign them by selecting these members. By default it is ISLB 600. You can select these members also. Go to the plan view. And you can select these members over here like this 1, 2, 3, 4 and 5. And select these numbers. And you can use, for this one you can use Purlin's ISHB 200 I'm going to use. Okay, they have not selected. So let me select them properly. 1, 2, 3, 4, 5, 6, 7, 8. And turn this side. Select these numbers. Be careful, you should not select the frame. See this, this is the sheet that you have selected. Okay, you should not select that. And these numbers are selected. This one is also selected. So now you can go to the ISHB 200 and now you can see they are getting highlighted. We forgot the end beams, those are also purlins. So select this one, this member, and we are on this side also this, and this. So these numbers also give ISHB 200. So we have completed the assignment procedure. All the members have been assigned and the model is ready for the application of loads. Now in application of loads, go to define load patterns, and basically we have dead load and live load by default we have. And then click on the wind load X direction, select the type as wind, and select the code as IS875. 2015, and click on add new load. Similarly, click on Y direction, wind, and this one, add new load combination. Okay. So go to the wind load plus wind load X direction. Go to modify lateral load, and you can check the parameters. Coefficient, windward coefficient and leeward coefficient are 0.08 and 0.05. These are available in the IS section for code book itself. These leeward and windward coefficients. So click on this exposure from shell object. So this, sorry, keep this one only. And the wind speed is these parameters also available in the code book. You can use these parameters and say okay. So with this we have applied the load patterns we have created. Now dead load. This roof sheeting is the dead load, and the live load of here is as per the standards. It is 1.5 as per IS 875. I 875 part 1, that is for the live loads. It is going to come onto the sheets. So what I'll do is that I'm going to select the live load on the sheets. I'm just simply selecting this sheets quickly. On this side also you can select these sheets. And go to the assign shell loads uniform. Click on the live load, and what is the live load? 1.5. And actually this live load, depending upon the inclination and other parameters, this live load also will vary as per IS 875 part 1. The live load also will vary as per the inclination. This theta value is there, no? As per that it will change. Okay. So for the time being, I'm taking it as 1.5. Click on apply and say okay. And what is this membrane? What is the weight dead load we have to give for this one, because it is not going to apply any load, so it is going to be dead load is going to be 0.5. So select all the 0.5 meters square. Okay, 0.5 meters square. So taking all the selecting all the frames. And now you can assign the shell loads, uniform load, and select dead load, and I'm going to give 0.5. The weight is 0.5 kilonewton per meter square is what I have assumed the weight of the sheet. This sheet, whatever is there, I'm assuming it as 0.5 kilonewton per meter square. Just a second. So if you calculate the inclination for our model, we have to uh, check this one. What is the inclination? And according to the inclination, if it is less than 20 degrees, then there will be windward and leeward forces. So this will be windward, and this one is going to be leeward. So here I am going to select all the frames. And I'm going to assign the shell wind pressure coefficient, and along x direction I'm going to give this as a windward phase, that is 0.8 I'm giving for the timing, but we have to calculate this 0.8 as per the IS 875 part 3. Whatever you calculate, roughly I'm taking it over here. So it's going to be 0.8, and that is I'm going to take for the leeward phase, and click apply on this roof. Okay, and say okay. On the other side, leeward phase, that here also the wind is going to act in the upward direction. It's going to pull it up, that is the wind is going to go and blow from inside. So on the leeward phase, I'm going to assign wind pressure, and on the leeward phase I'm going to take this one as 0.3 and click on apply. Say okay. So these are the forces that are applied. Now, if you have a trial version, the load combinations are not going to come. Now we have applied the dead load, live load, and wind loads. Now, what I'm going to do is that go to the define load combinations, and you can click the default load combinations steel frame section and click on OK. So these are all the load combinations that have been created, and you can say OK. So everything is ready. Now the model has been completed. The loading has been applied. The only thing is that you have to run the analysis. So simply click on this run analysis. So before that, you can save the model. Truss of size 16 into 8. Okay, and I'm going to save it somewhere else where it is required for my use. Here I'm change saved it. Now here I'm going to run the analysis. Click on run analysis, and we'll see what will happen now. So this is how it is getting deflected. This is how the structure is getting deflected, and this is for a dead load case. You can see over here my cursor is moving the displacement in dead load. Because of the dead load acting from top, it is getting compressed. So if you click on right side, we have start animation and an arrow mark over here. If you click on this arrow mark, it will go to the next load case, that is the live load case. So for the live load case, it is the uh, same kind of an diagram that is coming. Then if you go to the wind load, we'll see what will happen. So this is for the wind X, and this is for the wind step by 2. This is for the wind Y. There is not much in wind Y. We have not given anything, so it is showing for these cases. So you can go to the other option over here. You can go to the combination option, and you can select different combinations over here and see these shapes, deformed shapes. So this is the combination 2. Okay. There are many combinations. Go to combination 3, and you can click on apply and see this diagram. So this is the deformed shape of the structure, how the trusses are getting deflected, and how the members, all the columns are getting deflected. Right? It is a pin connection, and you can see it over here. Right? Next step is design. Now the analysis part is completed. You can also see the Benjamin diagrams also. You can go to the for the dead load. You can click on apply and say okay. So this is the Benjamin diagram that is coming onto the. So these cross members are having more bending moment. Then the purlins. Purlins are not affected much. That means that the section along this inclined number should be increased. Then you can go to the, for the live load, you can see the Benjamin diagram. You can also go and see the axial forces for the live load. See this one. So this is how it is happening. So you can see this beam is undergoing stress, and also the columns. So this is the correct action of the load and the axial force that is coming over here. This is how it's going to come. So you can take a screenshot when you're doing this model. You can take a screenshot and keep it in a PPT or in a Word document so that you can submit as an assignment. Okay. So this is how you have to model it, and you can see the bend moment and shear force, axial force diagrams over here. Then next step is design. So in the design, is it clear so far? So far, is it clear? Students, are you following? Unnara, Asli మీరు ఉన్నారా?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So after this, go to the design option. Click on this design option and go to the frame design, steel frame design. View preferences, that is the code according to which code you have to design. As per the Indian standard or American standard, you can select different types of codes that are there, and you can use these codes. And these are all as per the Indian standards. These are all the factors that are coming, and you have to uh, see these factors. Okay, these are standard factors. No need to change them. Just go through these factors for subject point of view, and then click on OK. Next, go to the design frame and click on start design group or select design combinations. So if you click on this one, you have to check whether all the combinations are selected or not. That is, the design is running as per this combinations or not. You have to cross check. So it is already selected. So then you can go to the design and click on start design check. Click on start design check. You click on this one, it is going to analyze. The entire frame has been analyzed, and the members are reflected over here. All the members are coming in this color, where is in this color, which is a range of 0 to 0.5. Okay, so here it shows that the safety is it is very much safe. That is, the capacity of the member is very high and the load is coming is very low. That shows that it is not economical. That is, like you're using heavy sections rather than the required. The required sections are lesser than what we have used. So we have used for the column, we have used ISHB 200, and the interaction ratio for this is like let us see the interaction ratio here. Go to the design frame, and here you have display design info. Over here, PM ratio. You have to select this PM ratio, click on apply, and say OK. So the ratio over here is coming as 0.238. If you see on the column, 0.3 and 0.33. So the capacity is 1. It should be like, it should be close to 1. That is still the strength of this, like it is 0.23, right? So out of 100, if you take 0.23, it is around 60. 67% still the column can bear the load. So only 23.8% only the column, the load is coming onto the column. Still the column capacity is 67%, still it is having more capacity. So on the higher side, the columns are on the higher side, so that you can reduce these sections. Okay, that means you can even reduce the section size. So what will happen if you reduce the section size? the weight of the sections will be reduced and the cost also will be reduced. Okay, so what I'll do is that I'll click on this member, right click on the mouse, and here you can see the analysis and the design section is IS HB 200. So I'm going to override that section. So click on this override option, and here current design section is ISHB 200 type 2. Click over here, and you have ISHB 150 which we have selected. Click on this ISHB 150 and say OK, and say OK. Now the ETabs will automatically do the analysis again. Now this time we got 0.45. Still this section is also very high. So what I'm going to do is that I'm going to go to the properties, frame sections. I'm going to, okay, I cannot add it because the model is locked. I'm going to unlock this model, and I'm going to add some more sections, lighter sections I'm going to add. I'm going to import some more lighter sections, Indian, FE250. So ISHB 150 is there, then we have ISMB is there, ISMB 175, ISMB 150, 175. I'm going to take these sections. Okay. ISMB 150 and 150 and 175. I've chosen these members. Say OK. Now once again I'm going to run the analysis. And then once again I'll go to the design and click on start design check. And now this time this ISHB 150, I'm going to overwrite this section to ISLB 150, that is light beam. Let me check whether it will carry or not. Now it is coming as, what is the ratio it is coming? Go to the design frame, display design info, select PM ratio. Let's see. Now the design is coming as 2.6, that is it's failing. It is more than 1. It should not be more than 1, and it should not be very less than that. If less than 1, if it is very less than 1, like that is if it is 0.5 or 0.4 or 0.2, it is not economical. So we have to change these sections according to the ratio, that is PM ratio. It should be 1 only. So if the sections are less than 1, the sections are all safe. Of course, all the sections that we have used are safe. Everything passed. That's why they are in this range. But it is not economical because it is the carrying capacity is very high. So you can reduce the member sizes so that they can take the truss will be in an economical stage. Okay. So with this, we have completed the analysis of truss and modeling of the truss. You can change these sections according to the requirement. So have you followed this carefully? So now you can ask if you have any doubts, you can ask regarding the modeling of the truss and application of the loads and any other point you are having. Anyone? Can anyone ask anything? And afterwards, don't say that, sir, I did not understand this, because next week it is over. I am going to upload the assignment 1 as truss, and by next week, everyone should have upload the screenshot. You have to take this screenshot of the bending moment, shear force, axial loads, and the entire design this diagrams, and you have to upload in the GLA. So that is what you have to do for the next class. So in the next class, the truss is over. In the next class, we are going to model a new structure. Okay. Say yes or no.
Yes, sir.
Yes, sir.
So I have given you the sizes, different column sections, so different plan and elevation sizes I've given. So as per the sizes that I have given, you have to model the structure for that. And Murthy, you said that you will show it in 15 minutes.
Yes, sir.
So can you share your screen now?
Sir.
So please remember one thing, everyone. Here, I have shown you the previous videos. Different engineers will follow different procedures, but the output is same. Please remember that they follow the different patterns and different procedures, but the final analysis result should come same. The loadings and the result should match with all the engineers. So I'm giving you as a co-host. You can share the screen now. Yeah, it seems to be good, right? Fine. Um, yes. So did you apply the loads for this? So go to the display nodes, go to the display option. Yeah, dead load, collateral load, and wing load. One. Okay, fine. Go to the display option. Yeah, go to the display option. Go to display option, and here load assign. Click on load assign. Frame loads. Click on the frame load. Then select the live load. Click on this load patterns and click on live. And then go to the next turn. You have not given dead load and live load. That's why they are not reflecting. Next, go to the open it. Open the window. Load patterns there now. Click on that. Click on the load patterns. No. This one only. This window only. Oh, here, there on live load. Then click on collateral load. Collateral load. You have not given the loads. If you have given the loads, you will get apply over here. Then you can apply. Then again, open that window again. Go to the collateral load and open that taskbar again. And click on Wind 1. Click on WL1. No, you have not given loads. You have just modeled it, and you have not assigned any loads. Okay, close it. So you have to apply the loads. So far, whatever you have done is good. see the videos where you can understand the loads, how to assign the loads, and then you can so stop screen sharing now. So others, what about others? So no one else have completed the geometry part at least. Others, have you completed the geometry part? Anyone who have completed the geometry part? No one is completed. So next week I'm going to check completely, including the design part. Everyone should upload the assignment. I'm going to share my screen C. Here I'm going to open an assignment for you. The new assignment is now only I'm assigning the. Can you see my screen?
Yes, sir.
Yes, sir.
In GLearn, in structural engineering, I'm giving the assignment now. I'm adding a new one. It is analysis and design of a truss. Okay, so I'm giving this as maximum 10 marks, and the last date is November 5th. Okay, it is an online assignment. So what you have to do in this assignment is you have to take the screenshots of the bending moment diagrams, the shear force diagrams, the axial load diagrams, the members what you have used, and this one you can take a screenshot. Okay, take a screenshot, upload in the Word document, and then you can upload in the GLearn where I have created the assignment. You can upload over here, right? So with this, I'm ending class over here. Now, if you have any more doubts, you can ask. Otherwise, I'm going to end the session. By the next week, you should upload. Everyone should able to upload the bending moments, the axial forces, the design part of this truss should be uploaded. So say yes or no.
Yes, sir.
Others,
Yes, sir.
Shankar, Balkrishna, why did you
Yes,
come so
sir.
late? Why did you come so late? Vivek,
Yes, sir.
Balkrishna, why did you come so late?
Sir, morning exam ఉంది సార్
ఏం ఎగ్జామ్
SSCJE సార్
ఆఫ్టర్నూన్ ఏంటి ప్రాబ్లం
రావడానికి టైం పట్టింది సార్ కొంచెం ఇంటికి
but you can log in, no? You can use datanet and get logged in. Okay, fine. So I hope next week everyone will complete this model and you will upload in GLearn. Thank you very much. I am ending this session.
Thank you, sir.